Alright, welcome back, guys. First, credit to the authors of this material. This material is from Jam. It's an extract from Jam Remix. Please note, we treat a lot of extracts from different materials. You practice the questions with me. Let's go into it. Pressure and Pascal's pressure. Uh, Pascal's principle. 1. Which of the following statement is correct? Which of the following statement is correct? A. Cross-sectional area of the tube weight. The reading of pressure on a mercury barometer is independent of the cross-sectional area. That one is a common knowledge. Number 1 is option A. When you read pressure on a mercury barometer, it is independent of the cross-sectional area. 2. The principle of transmissibility of pressure in a fluid at rest is in all direction is known as 2. Is known as Pascal's law. That's Pascal's law. You see the principle, they didn't state the law, but it's under Pascal's law. 3 has to do with calculations. 4. Let's go to 5. Which of the following statement about liquid pressure is not correct? Which of the following statement about liquid pressure is not correct? They say at a particular depth depends on the sphere of the vessel. Now lie. It is actually independent of the shape of the vessel. So 5 is option E. 6 has to do with calculation. 7. Let me see. Let's go. The figure above shows an inverted U-tube with inverted means then turn upside down with the open end O here of one link below the level W, which is this one. In this diagram is not clear as much as possible. Below the level W of the water in a tank. In order that water should begin to flow from the tank, it is necessary that 7. It is actually necessary. Let me see. It is necessary that the U-tube is completely filled with water and P should be lower. This place should be lower than W. Should be lower than this W. So number 7 is option D. 8, 9, 10. Next 12, 13. Which of the following devices are used to measure pressure? Listen, devices that are used to measure pressure. 13. You use anaeroid barometer to measure altitude, and you also use manometer to measure gas pressure. Write down anaeroid, A-N-E-R-O-I-D. Anaeroid barometer is used to measure altitude, while manometer is used to measure gas pressure. 13 is option D. I, anaeroid barometer, and IV, manometer. 14. 15. Which of the following is the most suitable to use to measure altimeter? Abi? Which of the following is the most suitable for use as an altimeter? 15 is option D, anaeroid barometer. 16, 17. Okay. Has to do with a bit of calculation. 18, 19, 20. Which of these statements are true of pressure in liquid? Which of these statements are true of pressure in liquid? I, and IV. First, pressure acts equally in all direction. Pressure decreases with depth, and IV, pressure is dependent on the cross-sectional area of the barometer tube. 20 is option C. 23. Which of these statements are correct for the pressure in liquid? Which of them are correct? The pressure in a liquid at a point acts equally in all directions. That's correct. The pressure increases with depth. That's correct. And the pressure at the same depth in different liquid are proportional to the density of the liquid. 23 is option B. And compare it to question 20. 24, calculation. 25, 26, 27, 28, 29, 30, 31, 33, calculations. 35. When cold water is poured onto a can containing hot water, the can collapses because what causes the can to collapse is, let me see, option C, steam expand. No. External pressure becomes greater than the pressure within the can. The external pressure becomes greater than the pressure within the can. 35 is option D. So when cold water is poured on a can containing hot water, if you try this thing, if you doubt them, get this can can Coca-Cola, can malt and the rest. When you finish this thing inside, heat serious water, pour them inside. Then, but you need to seal them properly because some students will be like, I tried it, it didn't collapse. You need to seal the top properly. Then you could, if you have water you just brought, you just melt an ice block, you just melt, pour it on top. You see what will happen to it. What actually happened is because the external pressure becomes greater than the pressure within the can. 36. Remember I said whenever you come across this type of question, go to the question first. Which of the above conditions would not affect the pressure of fluid? 36. Density of the liquid. Yeah, density know they affect pressure, and also acceleration due to gravity know they affect pressure. So I and II, option D. 36 is option D. 36 is option D. 38. I and I, that is 38 too. And they repeated the same thing again in question 38. 36 is option D. 38, let's try it out. They say, in which of the statements above will pressure be dependent? It can be dependent on the density. No, they affect them. Depth below the surface of a liquid. The surface area of the liquid is supposed to be I and I. 38. Let me see. I. Wait, is dependent. Pressure is dependent on. If we go back to question 1, let me give a note here. Let's write down. The pressure depends on the height or depth. It depends on depth or height. It also depends on the acceleration due to gravity. Alright, we'll be back to question 36. I need to correct some lapses. They say, which of the above conditions will not affect the pressure? Will not. Density of the liquid will affect it. Acceleration due to gravity will affect it. Type of the container will not affect it. I will not. IV, the constituent of the liquid. The constituent of the liquid. Which of these, let's say again, which of these conditions will not affect the pressure? So the most likely answer here now, let's go. There's a I, density of the liquid, and I. The major one is the type of container. I think this question is framed wrongly. It's supposed to be, see, which of the conditions that will not affect it, or probably the options are placed wrongly. It's supposed to actually be this one, the container, because the other ones will affect it. The density, if you know the formula for pressure, you get pressure is equals to density G and the H, which is the depth, and acceleration due to gravity. So density will affect it, acceleration due to gravity will affect it. See, the constituent of the liquid, we'll go with option C, the type of container and also the constituent of the liquid. The constituent of the liquid. Option C. So let's go to 38. Now we could make, so we'll go to 38. See, in which of the statements above will pressure be dependent? Density of I, depth, I, surface of the liquid. In which of them will it be dependent? I and I. So 38 becomes option C. You get 38 becomes option C. Let's take 38 becomes option C. 38 is option C. So 39. The pressure at any point in a liquid at rest depends only on the depth and the density. You see now 38 is option A. So I'm happy we went back to do that correction. I observed that. 40, mercury is suitable as barometer fluid because 41 because it's several times denser than water. 41 is option C. 41 option C. 43, mercury is a better barometric fluid than water because 43, 1, it needs no coloration. I, correct. And 43, its density is many times greater than that of water. I and I, option A. So 44, which is the last question.
They said, which of the following statement is correct? Pressure exerted is higher than within a narrow heel shoe than. 44 is option A. The pressure exerted with a narrow heel shoe uh, is higher than the one exerted with a flat heel shoe. So 44 is option A. Right, if you've gotten to this point, well done. You've done a lot. Now, if you're able to make the jottings or also correct the mistake I made earlier on pressure on question 36 and question 38, you could also snap your note and send to the WhatsApp group for assessment. Please be notified. We'll run a daily class to help you prepare for your next exam. If this is your first time and you'd like to join us, I will leave the link to the WhatsApp group in the description box. Hit on it and you could enroll and join us. Thanks for watching. I'll see you in the next chapter.